Right. Well, I didn't want to go live for the sake of talking with Ted and going through his stuff, but now we're good. Right. So until recently, until like computing power has become less and less expensive, and now it's more feasible to train these huge machine learning models like ChatGPT. Um, Linear regression, statistical models like classic statistics, you would get a better result than doing something like a deep learning model like TensorFlow or a neural network if you had like a smaller amount of data. So statistical models are certainly they've not been replaced by any means. You can still, in fact, so much so, statistical models will give you you can learn about your data through them. You can learn specifically, like if we're looking at our wine, for instance, we can see the exact coefficient that pH has on alcohol, and we can map that, or we can see what that looks like as like a plot, and we can say for certain that pH has an effect on alcohol. Or actually, it's probably the other way around. Alcohol probably has an effect on pH. Either way, we could see that with statistical models. When we get into these bigger deep learning, machine learning models, we start to lose any of that visibility, and suddenly the model itself just becomes a black box. And stuff goes in and the answer comes out, and the answer's right, but we can't necessarily get the sort of mathematical values that mean anything to us like we would with traditional statistical models. So still very, very valid. So yeah, let's get into that. And I will try to do this quick so then we can move on to people's data and walking through stuff and doing actual lab and QA stuff like we did last class. So traditional statistical models. So there's it falls into two basically. And this even goes into sort of machine learning as well. I mean, for like 80% of stuff. So linear regression means that the value that we are trying to predict is like some sort of numeric value. So like if I made a linear regression model on the price of flights for a time of the year, maybe the things that I would put into that model are when my flight is, where my flight's going, what airline, time of day, maybe weather, something like that. Like all those things would feed into my model, and then the outcome would be like a dollar value. Like the model thinks that it's going to be one-way trip of $200 or something like that. So when I say a numeric output, and when we talk about linear regression, that's an example, is like money or temperature or something that like doesn't have like an exact value. It has like it has an exact numeric value, but it's not like a classification. So the opposite of that would be classification, which is logistic regression. And so traditionally it is binary. It's when we're just trying to get a true false value out of it. So like maybe I might use that same data set to figure out if my flight is going to be late. Not the amount of time that it's going to be late, but yes or no, is it going to be late? Late equals true, not late equals false. That's logistic regression. And so those have, if you've been in any sort of privy to any sort of analytics, maybe you've heard of that. Linear and logistic regression, I believe, are both models that you can train in Excel, which I just recently learned about, which like is kind of crazy. Also, I bet ChatGPT could put together a very rudimentary, not even rudimentary. ChatGPT could probably put together a banging regression models for you if you really wanted to. Maybe we'll mess around with that if nobody has questions later on. So yeah, those are like the two. Yeah, go ahead.
I understand logistic regression right here.
Yeah.
Can you go over linear regression one more time?
Yeah. So linear regression is when we are getting, there's like a range of values to get, right? Like, so with the price of like an airplane ticket is not just going to be like $200 all the time. It's going to be like $200.24 or something like that. So it's just a numeric value. It is, and that's That's the difference. One is classification, yes or no, or maybe there's more classifications. Maybe we're trying to get color, red, yellow, green, or something like that. So we have 3 distinct possibilities that can come out of that model. That's classification. The opposite of that is anything numeric that's on like a range. So like temperature, price, blood pressure. I don't.
That's what you mean by continuous outcome.
Right. Yep.
Okay. Thank you.
So yeah, those are basically the 2. All of these other ones are essentially offshoots of those. ANOVA, or the analysis of variance, is sort of when you compare 2 models to one another, or you compare 2 groups to one another to see if they are statistically different. And so what we did is we sort of did the intuition that you would maybe do that as a visualization, and then you would visually see that difference and be like, oh, okay, if I want to statistically prove that the pH of 3, if I want to statistically prove that's different, I'm going to do an analysis of variance on it. And that's going to give us a p-value, which we talked about a little bit early on. Basically, the p-value, if it's very, very minuscule, we're going to be able to statistically say that there is a difference. That's also sort of how a chi-square test works. I won't get into chi-square too much. That's like pretty hardcore statistics. Well, pretty old school statistics and hardcore, I guess. But time series analysis is another application of logistic regression. I'm sorry, not logistic regression, of linear regression. So time series analysis is when, let's say we want to forecast the rain that we're going to get in a particular state. If we saw that as a graph, we would see that like the rain is like heavy in the spring, and then it goes down over the summer maybe, and then we see it ramp up in autumn, and then maybe we see precipitation in the winter, obviously. But every year we would see something similar, right? We would see like a similar seasonal sort of pattern. So time series analysis can sort of extract that pattern and sort of take out the seasonality and see if there's like an underlying trend. Like, are we seeing rainfall increase year over year based off of the seasonal trend that we're able to extract from that data? Time series is old school too, but again, it is super, super legit, still being used for a lot of things. One thing that it is not good at is stocks, because stocks are very volatile and very chaotic, and they don't typically follow any sort of seasonal trend. But where we can see seasonality, time series is pretty good. It says stock price here, but I don't necessarily.
And that's crazy. That's what stuck out to me. I'm going to figure out what
So traditional time series can't do that. There are applications of time series that use deep learning that get a little bit closer, but a lot of those have non-traditional inputs in terms of like, how is the economy doing? Like, are there other factors that we can put into this that will tell us yes or no? And then it further gets muddied by the fact that, certain owners of Tesla can go on Twitter and tell people that he's going to sell Twitter's shares of Twitter for a certain amount of money and crash his own stock and then not go public with, and they're like not go price. So like there are things that can mess up stock prices, but that's a whole nother bag of worms, I suppose. So these are again, all of these methods have been around, some of them for maybe like 1800s. I think I'll have to actually look at that. 1900s at the very least.
for us that are like want to go back to school, I know you have to take statistics. That's what we're going to go.
Yep. Oh yeah. Linear models will be a class. If you go back to school and take statistics, you will very likely do linear regression. And depending upon where you take it, they might have you do it in R, but I'm going to show you how to do it. I'm going to at least show you. You guys have the notebooks on your computer already from Anaconda, where we are going to do some of this, and you can see what it looks like, so you can do it in Python later on if you need to. and it's pretty straightforward. Scikit-learn, is the one that we're going to be using. We've used it previously. That's the one that we had to import as sklearn, but you download it as scikit-learn, and it's a whole debacle. But anywho, that's that one. So yeah, if you do take a statistics class, you'll definitely deal with ANOVA and chi-square, and those will sort of be the intuition for linear regression. Logistic regression and time series are more modeling application of traditional statistics, but linear regression is like straight up stats. Like, it's great. Machine learning breaks down into, it used to just be two, but now with models being able to sort of learn from themselves, there is sort of a new, when I was in school, this third one didn't really exist. Reinforcement learning models, those were very, very new. But the ones that are a little bit more traditional, that if you take, if you take a machine learning class now, you'll probably deal with a lot of these. Decision trees is relatively straightforward. It's sort of like, so if we go back to the wine data and we think about pH, a decision tree is essentially gonna be like a tree where we're gonna have, like, if pH is greater than 3, we're gonna take this route, and if it's more than 3 or less than 3, we're gonna take another route, and it's gonna split into all these different ways depending upon all of the different factors that feed into our model. It's pretty. You can get a lot of insight from that, and they can be pretty decent models, but they do. The more decisions that you have, the more your model does what's called overfitting. And overfitting is when on your training data, it does such a good job that when you introduce new data, it has no idea what to do with it, because it's so perfectly fit to the training data that there's no robustness to it. So when it gets new data, it just completely overshoots or undershoots. So random forest is similar to decision trees, but it's making these sort of cuts randomly, as opposed to decision trees is going to go from like column to column to column. Random forest is going to do it on a more random basis. So this gets closer and closer to the sort of black box that I've talked about. We're getting less and less insight from the inner workings of this model, but our output looks good, so maybe we don't care about that. And then support vector machines is even more so. Like, you're not gleaning any insight from the model itself, only the output that it produces. And then neural networks. Interestingly enough, neural networks were conceptualized in the 60s, but they didn't have the computational power at that point to actually prove that they were useful until, I believe, like the mid-2000s is when they started to actually be able to do them. But they are loosely modeled on how the human brain works. We will do an example of that one, but again, the more complicated the model gets, the more it turns into that black box where we don't know why it works. We just know that it works. And that drives some people insane, like me. Not really, but it can be tough when a stakeholder comes to you and says, oh, is it because the pH was higher that sales went up? And it's like, well, I can't actually get that information from any of these machine learning models. But from a traditional linear logistic regression, we could go in there and say, like, yes, actually, it goes up by 5 points as opposed to a lower pH. Like, so that's sort of an example of what we lose when we get into these sort of black box models. There are supervised learning, and supervised means we know what we want from this model. So again, if I have a model where I want to forecast the ticket price, a plane ticket price, that's supervised because I know exactly what I want from this model. I want it to output a potential ticket price. Unsupervised is when we have data and we don't have an outcome that we are trying to model. So a good example of this is grouping. Like maybe we have a big, and we were kind of doing that with the pH data because we had pH data from like all over, like a range of continuous values, right? And then we grouped it into ones that are close to 3 and ones that are close to 4. So that type of grouping could be considered unsupervised grouping, where we are clustering together data into like a new group or a new category. That's sort of the easiest way to describe it, because hierarchical clustering and principal component analysis are like dimensional reductions. And for the sake of this class, we can just know that they exist, and that they're nice to have in some cases. So yeah, new to this is reinforcement learning models, where you sort of have an algorithm that can then sort of learn from itself or learn or like readapt to new data. And so that is Q learning and deep Q learning, which I have not used either of these before. It has not ever been in my purview of my data science or data engineering career, but they exist. So there they are. Cool. So now we are going to get into application of some of this stuff. Mostly we're going to talk about traditional stats, but we will do a little bit of the machine learning stuff too. So let's go to, if you haven't launched Anaconda, get that going and launch Jupyter Lab. And then make sure that we have Intro to Machine Learning is one of the folders that I put in Slack. It was a zipped folder that you should be able to unzip and get this out of it. And we'll look at all these tabs I have open. Oh, my Lanta. Close all of them. We are going to open up 1.3 linear regression. And no kernels. All right. So this is going to, I'm just going to kind of roughly show you what this looks like in Python. Again, you have this notebook as a reference if you ever find yourself needing something like this. But I think more importantly, there's a particular visualization in this that should kind of click in your head as to sort of what's going on with linear regression. And it should be apparent in the name. Linear means line regression. So we're going to go back to high school algebra or college algebra or whatever, whenever we learned mx or y equals mx plus b. That's largely what this is. So I'll start going. If you guys aren't there yet, just get there when you can. So let me run all, make sure everything's good. Yeah, it's all good. Okay. Did it open? Is it trying to open the folder? Remember how we opened the zip file?
Yeah, I have it with the green like box, and I have it red over here. I'm looking at it. I typed it exactly how it is over here.
Okay, yeah, I'll run this and then kind of chat about it, and then I'll come take a look. So as we do, pandas, we're going to use matplotlib in this one. I would use Seaborn, but this is the Anaconda one. And then from sklearn, we are importing linear regression, which is one that we talked about. So this data set is just kind of made up data. And basically we have X and we have Y. And so we are going to try to predict our Y value based off of what we can understand about the relationship between these two. And so basically, if we plot all of these as X, Y coordinates on a grid, like we did hopefully in high school or whatever, we should see a trend line, right? And so if we can mathematically calculate what that trend line is, given this stuff, that is our linear regression, quite simply. That's all that it is. But we're using a method called ordinary least squares to calculate that. Ordinary least squares being what you used to have to do with matrix multiplication before computers did it for us. So yeah, so here we're just extracting these two things. We're saying I want the X from X and the Y from Y. They did it really weirdly. I probably would have done like dfx, and that would have done the same thing. So there's different ways to do things. Anywho, so that's great. And so the linear regression wants to, when you want to train a model, it's called fitting the model. You're fitting it with the data. And so X, again, is the data that we're always going to know. This is the data that we always will have. Y is what we're trying to predict. Remember when I said the difference between supervised and unsupervised? This is supervised because we know that we're trying to predict this Y value. And again, Y is 10, 15, 15, 14. It's this column. This is what we're trying to predict. And so when we do that, we get M, which is essentially our slope, and we get B, which is our y-intercept. There's a lot more that we get from this, but for the sake of understanding visually what a linear regression is, this is what it is. Remember, these are our y value or our x values. These are our y values. And like if we plotted these, actually, and I think we can do it, comment this out. Yeah. So if we just plotted this, the values up here, this is what we would get. So we can already, you can even see, like it looks like the higher you go on the x-axis, the more it goes up. And so we could like haphazardly draw something in there, but what linear regression does is it uses ordinary least squares to calculate, to optimize the line that is the closest to each of these points. And so that's what this is here. And so in a nutshell, that's all that linear regression is. It's trying to find a line that fits the data the best. Now, in this case, this fits it pretty good. Like there's obviously, it's not perfect, but it's pretty good. Like if I had to guess for 4 that we would be around 12.5, 13, and we were only 2 off, that's not too bad. Depending upon where we're at, depending upon what kind of data it is, maybe that's negligible. But maybe it's a whole lot better than being like, I bet it's going to be 25. It's like, well, where's the business? Like maybe there's some business, what do they call it? Like people that, not business logic, anecdotal business knowledge. That's what they call it. They're like, oh yeah, no, I know that number 4 is going to be 25. And it's like, why do you know that? It's like, I've seen it in the past. It's like, great. If you can't show me the data, I'm not going to believe you. I'm going to trust this linear regression. That's basically why we use models, is so we can either validate or invalidate anecdotal business knowledge. Yeah. So, but does this make sense? Because see how what we're trying to predict is this y, and see how that's a continuous value. It's not just one or the other. It's on this range of values, these continuous values. And so, yeah, that is different from logistic regression. Logistic regression gets a little weirder because we want to use this sort of mindset of having a graph that we can see things fall on. But that's a little bit harder to do with things that are, classifications. So we're going to look at this, and if this doesn't make sense, that's okay. When I first saw it, it didn't really make sense to me either. But basically here we have a similar data set of X, but this time Y is either going to be 1 or 0. This could also be considered like true or false. And so the way that mathematicians sort of figured out how to do this, but still sort of give us an output, is instead of giving us a range of values, we get a range of values between 0 and 1. The difference is we just cut it off in the middle and say, if it's above 0.5, it goes up. If it's below, it goes down. And so we cut it off at that. What we're doing is sort of producing or predicting the probability, and we're saying at 0.5 it's one or the other. And so if we just plot it, just like we did in the last one, we just see we have some down here and we have some over here. But we can already sort of see something here. We can see ones that are closer to 1 tend to be down here, and when we get towards 10, they tend to be up here. So if we did sort of try to graph this, and we're going to fit our stuff, we would get something that looks more like this. It doesn't look great, but it is a fair representation of sort of what we're seeing. Like down here, the probability is super low or super high that it's 1. Like these are closer to this. And as we get further out, these get further away, but they also get more sparse, right? There are none down here by 10. Versus if we go up, as we get closer, as this curve kind of gets closer to up here, then these start to sort of, we see them pop up here. So again, this is the sort of visual representation of what a logistic regression is doing. Again, I know it's kind of janky. The linear regression looks a lot cooler because it's very easy to see. It falls on the line. This is a little bit more like, oh, it's more over here, so they fall over there, and that's why, in my opinion, it's not a great representation, but it's still, I think it's decent. But yeah, so even just by being able to see this, though, we can glean information about like our predictors and like what we're like. We can say like, oh yeah, as X gets bigger, we see Y get bigger. Like that's awesome. That's something we could say, like this predictor has an increasing value as it goes up. With machine learning models, they're typically not this simplistic. They typically have more than one X. They have multiple things going into them. And so we lose this interpretability. But let's take a look at that anyways. We can look at multiple logistic regression, but there's no visualization. It just gives us accuracy. Naive Bayes is another classic statistical method. But decision tree is one that we talked about. I don't know if this has the visualization, but let's go ahead and run it all real quick. Cool. So we've got weather data for this one. So just looking at this, what do you think? What do you think we're going to be predicting? And what else do we know about the data? Just holler out anything. Ding, ding, ding. Yep, that's what we're doing. So that means it's a continuous range, meaning it will be a regression, not necessarily linear, but a regression. And then we notice that everything else is just ones and zeros, right? So all of the other predictors that are going into it are just ones and zeros versus all of our predictors here with X. It was just, this was our only value and it was also continuous. So right away we are like, oh, this is a different can of worms altogether. So yeah, so in this case, we are, and we talked about this a little bit early on, where we have a train and a test set, where we train our data on 70% of it, and then to see how well we did, we feed it the test set, data that it's never seen before, and we compare the actual value of, I think we're looking at temperature. Maybe they want to do, maybe they're doing something else with this. They're doing classifier for this one. So if it was regression, I would have done temperature. I forgot that they are doing, and this one they're just trying to figure out, is it good weather or bad weather? So good weather or bad weather means classification. So you would say, I would call it classification, which would be like a logistic regression, but in this case, it's decision tree. If we were doing temperature, then it would be a regression and our output would be continuous. But we can kind of see that here, right? Decision tree classifier, classifier signifies that we have a class, which means we have two or more distinct things. And so here we can see that we have our test set. Our size is 1/3. So 70% of the data is being trained on, and we're saving 30% to see how well it's doing. So yeah, basically it's saying it's 100%. Confusion matrix, I'm not going to get into right now. That's the type. Basically, yeah, I won't get into that at the moment. Basically, this one did it at 100%, which is great, but it's also the data that they could sort of show off with this. I wish that they had the actual decision tree. I thought that they did. I guess not. All right, so random forests. It's largely the same thing. And this is probably true for a lot of machine learning when you're trying to create a model and validate that it's actually good. Of the data that you have, you're building a train set and a test set, and you're training your model on the training set, and then you're giving it the test data it's never seen before, and you're comparing the actuals versus the predicted outcome from the model. Yeah, so I'll run this one. I think this one is good too. Run all cells. So this one, they are classifier. This one, I think they're doing the same thing with good weather. Hooray, it did it. So this one did it too. Kind of tempted to do this with temperature, but I won't do it. And so down here, when the model is being fit, there are different things that like you have to sort of parameterize within the model. I won't get into semantics of sort of what these mean, but it's sort of like on a TV. I don't know if anybody remembers like when you used to have antennas on TVs, and like it would look really crappy, and you'd have to go mess with the antenna. Or I don't know. My mom used to talk about her dad going on the roof and like getting the antenna on the roof and like moving it around. This is similar to that. I mean, you sort of have like when you first put the antenna down, you're like, I think it's going to work like this. And so this is sort of the initial shot of them saying, I think it's going to work like this. And they put it down, and then that's your sort of baseline. You turn on the TV and it looks okay, but you need to do some adjusting. Similarly here, depending upon what these parameters do, you might move them up or down, or give them a bigger depth or more features or something like that. That's the best way to sort of describe what's going on there. Neural networks. We'll do that real quick. Take a break, and then we will do some lab time. This should be able to run. So this data is, so these are RGB values. And essentially it's saying, is the color light or dark? So based off of what we know about these values, so like whatever this one is, actually, maybe I can do this. Let's see what this looks like. RGB. Oh. That's dark. Let's look at some other ones here. I guess it's kind of dark. This one. Maybe they've got it reversed. I'm not sure. But anywho, that's essentially what they're trying to figure out here. Light or dark. Maybe it's the type of font. But anywho, they're trying to train a neural network what colors correspond with dark, based off of and the thing of it is here is people think when you're training neural networks or something like that, like, oh, you just give it the data and it tells you. It's like, no, when we talk about training data, it's we already have answers for these observations. That's the only way that we can train these things is when we have the answer that we're looking for, right? So we have a bunch of data where we already know the answer to, and we train it on that. And then we have a little bit of that test data set aside where we can compare how well it's doing with a little sliver of that test data to see how close it is. And so this is, again, that's our predictor. This is a supervised learning thing because we know what we're trying to predict. So here, we put it in. It looks like they scaled down variables, separate and put yada yada. So they're dividing everything by 255. So they're turning these into basically decimals from like 1 to 0. They're using these fancy things with this stuff and that stuff, and who cares about that? Let's just see how well it does. 100% is what it's saying. So cool. That's really cool that we can do that. And neural networks have been around for a minute. It's funny because I remember thinking that this stuff was mind-blowing, and now we have large language learning models. But this is sort of was the predecessor to that, right? So it's still very cool and very useful. And I can run this on my computer, right? I'm not using cloud computing or anything right now. This runs on my computer. So it might make sense in wherever you end up. If you have enough data, it's like, well, maybe let's try a neural network and see if we can get some good predictions out of this. So that's what's great about this. So this is the classic. The MINT data set is handwriting. See if they have a picture of it. Yeah. So it's huge, 70,785 columns. So this thing is huge. These are all pixel values of handwriting. And it's training right now. This is probably going to take a minute. But I'm going to just Google this so you can see what this looks like. MINT data set. Yeah. This is what this data looks like. Every single row is just a different version of, can you not, that is not showing up. Why is it doing this? Weird. There. Okay. That's what the data set looks like if you actually take all those pixels and then map them out. So it is taking each of those and learning the letter or the number that it is. And so this was like, when neural networks were first getting going, this was like the gold standard. They were trying to get this to like 100%. And like when I was taking machine learning classes, like this was like hot stuff. It was like, can you get higher than 96%? Or something like that. And now I think that the one in here, is it still going? It probably is still training. This one does take a minute because it's a pretty large data set. My computer's pretty fast, so hopefully it goes pretty good. But again, we see some of these more things that this is the sort of, this is our, like, we're starting with this. We're going to see how well we do. And then maybe I'm going to go in here and maybe we need more hidden layers, or maybe we need more max iterations, or we need to increase or decrease the learning rate. And again, for the sake of this class, we're not going to go into in depth on what those things are, but they are things that we can use to reparameterize our machine learning models. And so I'm going to let this run. It's taking longer than I thought. It's 150 seconds. Oh my gosh. Yeah, while that goes, we will start our first break. So back at 7-Eleven, and maybe this will be done. Oh, yep, it's done. Woo! So our test score was 97. I don't think I got that high when I was in school. I don't think that we had multi-perception classifiers at that point. Or if we did, I didn't have the library. I'm not sure. And so actually, this, I will sort of explain to you what the confusion matrix is. So if we think about, we have 0 through 9 in this, right? So if we look down the side here, if we think of this as a 0, a 1, a 2, a 3, 4, 5, 6, 7, 8, 9, these are the actual values of our test set. And then the long ways at the top, this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 of our predicted values. So these should line up in the middle if they're exactly right. So the ones where they're off is like, this is a 7 and it was predicted as a 7, but it was actually a 0. I know it's hard to see this because it doesn't have the labels on it, but all these ones were misclassified ones. So previously we'd only been seeing like a 2x2 matrix, and there was just ones in the diagonals, meaning it was 100%. So like, this is interesting. So this is 0, this is 0, got that 100% of the time. Or wait, we got that a lot. But then we look at 1 versus 1. A 1 was never mistaken for a 0. So at least that one we got pretty well. Some other ones here, whatever, 7 and 3 or 2, those were never mistaken. So that's what the confusion matrix is. I don't know if that helps at all. Kind of confusing. But that's why we see that diagonal of everything lining up. Where we see these big numbers, that's where it was properly classified when we're looking at the predicted value versus the actual value of our test data set. And so then if we add all these up and we add all the missing ones up, we can see that we got it right 97% of the time, just about 98% of the time. So yeah, so that's how, and this is this TensorFlow or is this, no, it's not. So this is just from sklearn. TensorFlow is the one that Google put together, and it's the one that, like, I don't know if you guys have ever used like reverse image search from Google, where like you have a picture and you can upload it and it will find similar pictures. That's using like TensorFlow was the beginning of that technology, and it's always been open source. For a while, the military was trying to use it on missiles, and like, the people at Google stood up and they were like, this is open source, but you can't use it for warfare. I'm pretty sure they won that. I can't precisely remember, but I don't even know how they would know if it's open source. The military could be like, okay, we promise we won't use it. And then go to the side and be like, hey, we're still using it. But again, this was like 10, 15 years ago, and things have come a long way since. So yeah, so this is what we did to this training set, we divided it, we sort of grayscaled it basically, and then this is basically this is what the actual model itself is looking at. And it's funny because I couldn't tell you what numbers these are. Like, is that a 1? This looks like just a slash up here. Like, it's interesting that this is what the model is using to classify the things, and I can't tell what they are, but yet it's 97% right. It's, yeah. Computers, man. They're crazy. Okay. So that's all we will talk about that. I know that was a lot, but I just wanted to introduce to you that this is the type of stuff that people love Python for, is because we can do this stuff. There are libraries for it. And I know it looks crazy right now, but this is not a lot of lines of code, right? This is reading in the data, doing a little bit of manipulation, setting up train tests, setting up the actual model itself, and then running it. All of this other stuff is just for us to visualize it. But in reality, this is like not that many lines of code to make a neural network. Like it can be that simple. It is usually not, but this just illustrates the power of just a few lines of code. Okay, now we will take a break. 7:16. Oh, yes, of course. Yep.
I don't know if it's the way I'm downloading my data, but okay. So this is here. This is my data.
Yep.
If I click on it, it comes up just fine.
Yep.
Right here.
Yep.
Okay. I have import pandas as PD.
Yep.
Right. Now I do df equals PD.
Yep.
I read underscore CSV parentheses quotation. When I press tab, it's not going.
Okay, so it's because this is, I don't know why this happens. So there's your data there. This is not saved in this directory. So this is just looking within the directory that your file is in. So where is this file saved to?
My Twitch data file?
No, your Python notebook, sorry. So you're in final.ip.
Mm-hmm.
Yeah, where is this file located on your? Oh, yeah, actually, it just showed. Go hover over it. It's in OneDrive documents, Iterative Data Science file.
Okay,
so that's where you're
to move it to.
Yep.
Okay, that's simple enough. I was sitting here like, what am I doing?
I know. We were having similar issues with Brenda's data too, or Honest data. And then, so I'll talk about this at the end of class, but when you turn in your final, if you have a CSV you're using, I'll just need that too, so I can run your notebook.
Okay.
That's why sometimes it's nice to have just like URLs to read from, but then sometimes that data goes away, so it's better to have the real thing. Okay.
So this final is not like a folder on here.
What's that?
You said to save the data where my final IPYNB was.
Yeah, it looked like your final was in Intro to Data Science.
Yeah, so I moved it to right here.
Okay, so now it's there. So that may have messed up in your. Since you have it open, you might need to close it out in your Jupyter Lab and then open it up again.
Close this out.
Yeah. So you just moved it. Close that. Just save it just in case. Okay. Now, where is it again? Your OneDrive desktop, right? So you don't need to make it again. We're going to try and find it, right? You said it was on your desktop?
Mm-hmm.
Oh, you were already on OneDrive, right? Yeah. Drive, desktop. Or documents. There you go. What do you say, right? Is it in Python or?
Should be right here. But...
Fine,
Right
there
here.
it is. Okay. And so your data is in this folder too?
No, I thought it was. 1 second, it will be.
Shit. What was your data called again? It's the Twitch one, right? Yeah.
Mhm.
Okay. There it is. And so now you should be able to open up Final in there. And tab. Hooray! All right, let's get back going. All right, so I'm going to start with charities data. Oh, you need to run the first one first.
Oh.
Since you opened it up again, it probably restarted it.
Gotcha.
So let's see here. Charity's got mental health care in the last 4 weeks. So this is from, I think I have it open. This is from data.gov, which is one of the ones that I mentioned. And this is a survey, a pulse survey. I don't know if anybody's ever done those at work. They're annoying, but they can be helpful. But that was sent out to I don't think I filled one of these out, but American households on the social and economic impacts of COVID-19. So I'm pretty sure that this started in, I think the data starts in 2020. And then it looked like there was data like very recently. So I was telling Charity, like, this is something that you could, like, once you get a script built for this, you could run it like weekly and get new data. And like, that's cool. Like, that's like almost like you could do that obviously with the Python notebook, but then like you could also do it with like Tableau Public or something like that and always have up-to-date data with stuff like that. So this data set's really cool. But this data set is also nuanced. So let's take a look at what that means. Let me close some of these out. So off the bat, we see that there's a lot of stuff going on. We have indicator. So this took measure of mental health. Needed counseling or service, did not get it. So there's some stuff going on with indicator. I'm curious what all those look like. There's group national estimate by age, and then it looks like it goes by state too. And so then we could see that within there's state isn't just like what you would assume states. It is also the United States. And then there's a subgroup from that. So it looks like this first one is just a national estimate for this time period, 819 to 831. And so then we have the value, which I would assume is, let's see what that value is. Designed to meet the goal of accurate, timely, weekly. Okay. What does it mean? I think it means how well they're doing mentally. Gauge the impact of pandemic on animals. Interesting. Okay. So the first thing that I'm thinking here is like, you see state, and I'm thinking like, oh, I'll just like group by the states and maybe map that or do something like that. But then it's like, the state is United States. Like, that's weird. So obviously we need to dig into this a little bit. So we can do a df describe. And that gives us all of our numeric values. Don't have a lot of suppression flags. So then we have the value, and then we have CI stands for confidence intervals, which is sort of like, I would assume in this case it's 95% confidence intervals, which like of all of the statistical values that they got, 95% of them fall within these two values. So we can actually, let's take a look at that again. So here is the value for, again, the mental health. And then the low confidence interval is 19, and above that is 19.8, which means 95% of the values that they estimated are between this. And so right in the middle there is 19.4, which is what they would assume. So I don't know if we care too much about the confidence intervals for the sake of like maybe what we want to do here. But what I'm interested in is number one, maybe I want to read in this and tell pandas to parse these dates. So I might do that. Parse dates. And so remember, when we want to reference more than one column, we're going to make a list. We're going to make our square brackets. And so because I'm terrible at typing, I'm just going to copy them in there so there are no mistakes. And again, we can define this before we put it in there for the sake of readability. I'll do that. And because we've been doing that in the last classes. Date calls. So we'll define date calls as such. So that's what we want. We want those to turn into dates. We've said parse dates. Those are my columns. Let's see what it looks like now. And we'll run that. And okay. They look a little bit different. Yeah, now they're actual dates. Cool. So that could be good for plotting later. So again, let's do a count by group, because I believe I'm just going to start by this column group first, because there's a lot of different things in there. So I'm going to go group equals df dot group by, and it's actually, the name of that column is legit just group. Oh, I think it's capital G.
No matter capitalizing or
And then specifically, look by the index. See if I can do index. I don't think I can. I might have to. Yeah, that's what I thought. Oh, come on now. Okay, let's just see what this looks like. This is going to give me everything. So any that are just one. Here, I'm going to do a bit of here. There, now we have an actual index value. So I'm going to do this because now I have, this is like a primary key now. And so now I have something to count when I'm grouping by. I think there's a different way to do that, but I can't. Okay, so there's my group. I'm going to go group. I'm going to take that index and count. Okay. So there's quite a bit by age. Yeah. There's a lot by state. That makes sense because we have.
I seen one like underneath there where it said like took prescriptions.
We're talking about. Oh, let me do this real quick. Now there's two indexes. Let me read this back in. There we go. Yeah, so there's some indicator stuff for sure. So I might do a multiple group by here to sort of see what that stuff looks like. Let's do it. So let's go. We'll have groups equal group. And was it indicator?
Yeah.
I don't know how to spell indicator, apparently. I don't trust myself. Indicator. And so now we're going to group by these groups that we've said. Okay, so now it starts to look pretty wacky. So there's quite a few. Let me just do indicator and see how many different ones of those there are. Oh, there's. Okay, so there's only the. Gotcha. But they're very long. Yeah. So what I have learned from this is that each one of these indicator corresponds with a group and potentially a state. If it's national estimate, there's not a state. It's just the United States, right? Similarly with subgroup, We're not looking by age or anything like that. Phase and time period, I'm not sure on yet. Time period label, this makes sense to me. This is just a string version of what we're seeing here. So maybe that's helpful to me, maybe not. And then these values are just sort of where they fall within. Yeah. So I might do another DF describe again. And the other thing about, I think, final project stuff is like, when you're trying to figure out what you want to do, make a messy notebook. But just like when you find something that's interesting, like say like this is interesting. And then when you're ready to turn something in, just take the good stuff and just paste that over. Like it's maybe this is different than math class. You don't necessarily need to show your work in terms of all the scratch work that you did. If you want to turn that in because you did a lot of stuff and you end up with just like 2 things that you think are interesting, you can do that. But if the 2 things are truly interesting, I'm going to be like, heck yeah, that rules. That's all we're trying to do here is figure out what's interesting. So what I'm thinking here is I'd almost want to like look at this. So I probably for this, I mean, you could do this at a larger scale, but for the sake of the class, it might make sense to just look at the national estimate and then start seeing if you can plot that stuff. And let me see if I can show you what that would look like. Is that what you were thinking too? Yeah. I'm pretty sure we could do that with Seaborn. And if we can't, maybe for the sake of the class too, let's ask ChatGPT. Let's maybe look at Stack Overflow. Let's like, because again, this is the mindset that again, even with like some of the stuff that I'm doing, and even for this class, sometimes I'm like, oh, I can't remember that one thing because I haven't done it in a minute, and I have to do that. So it's totally acceptable, and it's why it's there. So I am going to make a new data frame. So if I want to filter just to get the national estimate, I'm going to do natnull, and that's going to be my new data frame. And I'm going to say df, and then I'm going to say df again, where group equals national estimate. And so if we run this, remember how we did this when we were looking at honest data, I did a thing where we compared dates to one another and we got the true false back. And then we used that to sort of like sort through the data. I'm doing something similar here, but I'm not saying, do I have an extra thing here? I do. Okay. I'm not comparing it to anything else. I'm comparing it to this string, right? Because the group that we want to take a look at is just the national estimate. So if we run this, and I know it's weird to see DF within a DF, but if we run this just by itself, there's our true falses, right? That's what we need. So if we want to, we can define this differently. We can say natnull test equals this. And then now I can just put that in here. And then because essentially by putting the true falses into this bracket, the ones that are true, it keeps that data. The ones that it doesn't, it just gets rid of them. So let's look at what that looks like. Cool. 152 rows. That's way more manageable to me, at least. And so now, yeah, this looks great. So now if we do group natnull equals natnull group by
She asked if I was on my final.
Oh, okay. Cool. Yeah, and I will get to other people too. Let's see, because we've done so you two, and then James and Ted, if you guys have questions too. So yeah, I'm gonna do this, try and get a plot going, and then how do you feel about this? Is this what you were thinking? Is this helping?
I think a little bit more. Yeah.
Great. So yeah, if we do this and then group count, and let's count by our index. Just got a movie sent to me from a friend. Great, thanks guys. Cool. So now we have, for each of these, we have 38 values, which again is, now we're getting closer to something that is more plottable, right? If we want to do something like that. Maybe we could group by this and find the average for these to look at data from the beginning. Because again, this goes all the way back to August 19th, all the way up until, only 2022. Maybe they stopped the national estimate after a while. That, I mean,
I
like,
thought it went all the way to April this year.
some of the data did. This one, this one. I wonder if it stopped.
Maybe they just updated the results.
Yeah, or maybe it's not sorted. I'm not sure. Yeah, this is, I would say,
During COVID, I think.
mm-hmm. So let's try and plot this. I want to do let's do line plot. And I don't even know if I want to do anything. I think time period start is our X. I think our Y is the value. And then I think our hue is going to be that indicator. And this might be an interesting plot. So let's see here. So X equals, actually, before I do this, I'm just going to do at all columns. I spell my own data set wrong. Of course I did. Nult. Oh, classic. There we go. So now I can just grab this stuff. So time period, start date. I want that as my X. For my Y, I want value. I know I can spell that. And then hue is going to be, that was our indicator, right? Yeah, let's try that. And fingers crossed. I think I need a time series plot to do this, but we'll see if this works. Could not interpret value time series plot. So let's see if all right, so let's get on here and go Seaborn, x-axis, date. Oh boy. So I think because I converted it to date, it didn't want it. Yep. All right. Let's try to read it back in. Out parsing it to date, of course. And it still got mad. It must, is it already? No, now it's a string. Well, I might leave this to you. Well, all right, we'll ask ChatGPT real quick. Whoop. Why is it big? Gonna do it off screen because I have builder trend stuff on there right now too. Oh, PD to date time.
Maybe remove the.
Let's see if this works. So, oh, I didn't put my data in here. This works. I'm fired. Don't tell Nate. Hey, it looks terrible. So it also looks terrible because I think I'm zoomed in super far. So this looks good on like the screen that I'm presenting and stuff. So let me make it small. Try and run it again. It's not that good, but that's also because this thing is huge. We could potentially do, so this might be something that you need to research. Is like, how do I make my legend equals false? Do that just to see what it looks like. Is it capital? Every language has a different, yeah. Okay, so we notice we can't really read these down here, and that's a huge bummer. And I think that's because we didn't parse it properly. So if I go back to parse dates and we put in our date calls, and I'll zoom back in here in a second so it's more readable. And let's go ahead and go run all. Okay. Starting to look a little bit better. We can probably, let me see if I can do, let me see if I have to do this real quick. So Matplotlib should work with Seaborn to allow me to sort of adjust it. So then, but I've seen this previously not do anything. Oh, never mind. It did it. So let's do legend is true. And let's see if I can spell true right. Still put it in the middle. I do like legend, error bars, estimator, markers, size. Yeah, so I guess I would probably leave it to you at this point to try and figure out how to resize legends, because that's a bummer. Because I think this is a telling plot. We can kind of read it here. So needed counseling or therapy, but did not get it in the last 4 weeks. So we kind of see that spiked a little bit during COVID. Like this, again, this is like when it was bad, December 2020, and then it went back down. Because I remember that summer, everyone was like, "COVID's gone," and then it came back, and everyone was pissed off. And then it looks like after this point, everything sort of plateaus, and you can kind of see that it does that for everything. You also kind of note that all these follow very similar patterns too. This is totally interesting to me.
I have a question.
Of course.
I'm trying to understand the purpose of length.
Of
Because
length?
It always comes back like 1, 2. So I don't know if I'm not entering it in correctly.
Yeah. Are you trying to get? Here, I'll come take a look
just
real quick.
like looking at like the qualifications for final, and I see right here where it's like understanding data structure, type, and basic like descriptive tactics. So
And these are all like
I did like
do some of
head,
these
tail,
things. Yeah.
shape,
Yeah.
and I was like, okay, I remember us doing length on the scavenger hunt, but I don't understand the purpose of it. So I was like, maybe if I like enter in the name of a column, it'll bring back something. So I know like on W3 schools, this would would count, from H to the exclamation.
Does it?
Mm-hmm. If you try it, it gives you back like 13.
Okay. So go back to yours real quick. So this is going to annoy you, but yours are that's in square brackets. So right now you have it in a list. And within the list, there is only one thing.
Oh, it's the bracket.
So if you take the brackets off, it's no longer a list, and now it's going to count all of the characters when you run length.
Okay, so but what about when I do like 999? It's just going to tell me how many digits is in 999?
Yep.
Oh, okay. So then what's the purpose of it in here? Is it like if you can't see all the data off to the side, you want to know?
Maybe, I don't necessarily know if it's terribly applicable with what you're doing right now.
Okay.
Yeah.
Okay.
Try and do length of just your DF. What does that do? And you don't need parentheses or quotations, but like just regular DF. So that's giving you how many rows.
Okay, and that would
Yep. So
make
that starts to make sense. And then, so if you did DF square brackets channel, oh, that's probably going to show you the same thing, just how many observations. Right, because it's just going to count the rows, I think. Should be the same. Okay.
Mhm.
So
Okay, I was
length,
like, that doesn't give me
Yeah.
anything
Length-
useful.
length is doing one part of shape, right?
Mhm.
Where length is giving you all the rows, shape is giving you that one and that one. Yeah, what's up?
Thank you.
Okay, so we talked about this last time. I was trying to do the Boolean, so I went to
Yeah.
the walls.
Yep.
So I was like, okay, let me do one for the next one. So I did it for the next one for Sephora, and I did it. But then this is like, is it? And it's because I didn't put both, right? Like it's only doing for Sephora.
Let's go back up on what is your other one called? So we have ultra new. Yeah, so you defined a new data set, ultra new.
So if I would have just left it as ultra new for the other one, would it then stay?
Yep.
Oh, okay. And then
Because you want to do everything. If you want everything to happen to the same data set,
that makes sense.
reference the same data
Okay,
set. Well,
so-
and it's okay that you thought that way because I have been doing things how you are. We're like, I'm going to create a new data
Right,
set
yeah.
and I'm going to do this.
So because I try to do, I'm like, okay, well, why can't I do both? So I defined this as
Uh-huh.
like,
Yep, those are the ones you want.
yeah. And then I was like, okay. Oh, it's on you.
Classic.
So I was like, okay, well, I kind of copied whatever was on as this one.
Yeah.
And I kind of like was like, how do I change that? So I put like new columns and then make a copy of that.
Yep.
And then I write within that, I want this.
I don't think you need to. You can just put DF as new columns. I don't think you need to do copy.
Okay, so then Oh, do you? What you mean? That's it?
Yeah, you can get rid of copy because no,
Oh,
sorry,
no.
just that. Yeah, try and get rid of that and run it again. So
Without
because your main data set is just called DF, right?
right.
So yeah, get rid of the period too, and run that. See what happens.
The new,
Error new. Just go back up.
which
to the
is what I define this as.
Oh, because you have it in quotations.
So
Because it's a list.
oh,
Because it's a.
not. You said that last time.
And that's okay. This is what I wanted to do in this class period, so this is all good. So now try and run it. Yeah, it's thinking hard.
All right. Yep. It says Boolean array expected for the condition at object.
Where? Okay, let's go back up. Yeah. I'm wondering where. Go back up. Sorry, go back up to your code.
I mean, they don't. If they're not Boolean, so is that what
Right.
you're saying? Because it's not Boolean, you can't. Because they're all would be.
Previously, you've just done one at a time, right?
I did only Ulta and Sephora, but there were two different
Right, and so you're trying to do them
all
to
together.
all of them. So you might have to
Go
loop
back.
through it.
Do I have to go back? Because I already defined these.
No, I just don't think it'll do all of them at the same time.
Okay.
Let me try that real quick. And so this, so yeah, I remember you showing me at this class last time. You basically, you saw something online where it used the squiggly brackets to do it, or something like that, and you were like, I don't want to do that.
Yes.
And I was like, you don't have to. You can just do it one by one.
Yeah.
And so I think that's what's going on here. So like,
Yeah, and I started doing that, and then I realized that it wasn't. It was because it was defined. It was all different. Then one wasn't showing up for the other one. So Ulta was working.
right.
Then I defined one for Sephora, and so the Sephora was showing, but Ulta wasn't. So I was like, oh, well, why can't I just do it in a list, like a list, define them as a
Right. So
thing.
that's called, this is going to sound nerdy, but that's called vector operations, which Python doesn't always like those. People typically do loops. And
So
we talked about that a little bit. Yeah.
for I.
So for
That
yours,
And
so
I did see that as an option, and I was just like, okay, how would I do it? So it would be then.
so for I in new CLS, and you would want df of I equals df
Would it be
I as type
and then parentheses
bool. Let's try that real quick
Okay.
and see what happens. That code's not too bad, and you understand what's going on there, right? It's saying like
you're saying
each one.
For the data frame that is in the new columns thing, you want to for all of that to turn into a boolean.
Right.
Is that right?
Yep.
Okay. Let me. Nerdy as you. No, just play.
Good. That's. I mean, I want you guys to feel comfortable to use these different things, but vector operations is. Yeah. Let's see what.
And why brackets in the I? Just curious. Because it's command.
Yeah, because what this is doing is then, so if one of your calls is Alta, what this is doing is it's saying Alta. That's for the first, whenever it's Alta, that's essentially, it's replacing the I with that string. That string is already in quotations. I don't mean to look over your shoulder, but
I was just trying to transfer it already.
Okay, now just put in DF and take a look at it.
Yep. Yay!
Did it do everything?
It did. No, these are all these were all Boolean except for these. These were 0 or 1.
Oh.
And I was like, why didn't they just do true or false? Like
For those
because that's why I sent you the
yes.
description. I'm like, this is the same thing. I don't know why they did true or didn't just do it
Right.
for all of them.
So you are dealing with data cleaning right now.
Cleaning, yep.
That's huge. That is, and you did it. So you should
Yay.
feel good about that. Yeah. Well, that's out, and that's why I'm here.
Do you want me to put comments as like what didn't work, just so then you know?
Yeah, if you want to, and I mean that's sort of what I was saying earlier. Like if you want to turn in something that's clean and here's all the insight that I got, great. But also if you want to turn in scratch work because it was a heck of a lot of headbanging against the wall to get stuff to work, I'll take a look at that too. It's whatever you're comfortable with.
I have a question in a moment, just about like reading the data, like, because I guess I'm trying to like how you're used to doing it. So when you look at the data, you're like, oh, this is interesting. I noticed that you know what to like look for with like a keen eye.
Yeah.
You know, add changes and stuff. And I think I already told you about that. Just like regular, just data literacy.
Yeah.
So
there's another like function similar to describe that I think will be helpful. Where did I put that? And I think that maybe that will help you get to that point of being like, oh, this is interesting. And I thought, this one wasn't running, but I'm pretty sure that there was something good in it. So the pandas profiling didn't work for me, and I don't know why, but whatever.
I kept seeing the word command, but is it argument? Is it a new argument that you're making or new function? I'm trying to find the right word that I'm like. I defined a new.
For which one?
Like when I was trying to do the Ulta and the Sephora, I was doing a new function, right?
New data set.
New data set.
Yeah. Okay.
So when you're trying to figure out what is null in the data, I did the aggregate function. You have to put the sum.
Mm-hmm.
Then I'm gonna do my parentheses, and I have to do my PD because that's what I renamed it as. And then dot is null. Then I do another parentheses, and I just put data frame, right? If I just do data frame alone, will it do it for the entire data frame to show me when something's null, or do I have to put like the name of the column and go by like each column?
You might have to do that, but there's something. You can do it that way. And that's sort of what I said. I was talking about last class period. Like if you know how to accomplish something just by doing it, like do it to this one, do it to this one, do it to this one, and just line after line after line, that if that achieves what you're trying to do, that's totally fine.
I tried to write it in a long list and it gave me an error.
Gotcha. Do you still have it up? Do you want me to take a look at
That's
it?
what I did too.
Yeah.
Gotcha.
Yeah, I just deleted it, but I don't mind like retyping it really fast.
I think you can edit undo.
Oh,
Yeah, try and do
Yeah.
that. And then let me see if I can find.
I was typing out everything. I forget about this. Undo cell operation.
Just undo. I just did undo and it'll do it and then undo it until. it's the first thing that comes up. in mind.
Oh, at the top here.
Yeah.
Okay, here it is. Okay, now I have it already. Type it back out.
See, girl?
Thank you.
Watch harder, harder.
Each one teach one.
All right.
All right, and we're at a break time. Take breaks as needed. I'm going to continue to try and find a few things. Where are the notebooks? There we go.
I call it a vector.
Yeah,
function.
yeah.
Okay.
So that's like when you just want to apply it to like everything at once.
Okay.
Python likes to do loops. Yeah.
Did you want to take a look at
Oh, yes. Okay, so
So I did sum, the alias, ismo, and I have my parentheses here, df, and I started the brackets, and then I ended it with two parentheses. I'm just doing parentheses for like these ones.
looks. Oh, okay. So remember, so you technically need another square bracket because you want to have that list within that square bracket. Remember how we did that with some of our other stuff where we would like define a list of the columns that we want, and then we would reference that list within.
The brackets confused me, but okay. It makes sense. I knew I was missing something. I thought it was parentheses though. I put two extra parentheses down here.
So if they're red, I think that means you have too many.
I have two. This is too
This is
many.
the weirdest. Does your guys' class thing change like on deep? No, I'm always like have to go back to that.
Are you running Chrome? Interesting.
Yeah, but it only does it, like when I stop using it, when I'm not on it, like playing with it, it will like, and it's only the class 7.
That's so weird.
Or is it, wait, class 6. Class
I
6,
was
which
missing a
is,
bracket on the end too, so I need to put an extra bracket down here and then the two parentheses.
Did it work?
Let's see.
Okay. Unsupported. Let me try and recreate that.
Okay.
So I think there were a few nulls in this data set. Wait a minute. This is not it. This one. So back. So we have some nulls here for quartile and suppression range. Let me just do a little copy in here and go down here. Above. So net null. So my calls that I want are, oh boy, these guys. This guy. And so then I have calls. That gives me just the 2 is, I gotta do PD. Is null. Yes, so I'm getting the same thing as yours.
Okay.
So this is the same thing that she was dealing with. I would probably loop through this. So for I in calls, and I'll show you what this is doing first. Print I. So I have two things in here, right? I have quantile range and I have suppression. And so when I say for I in calls, I typically means iteration. So I'm going to iterate through. I'm going to go the first one and the second one, and then the third one, fourth one. In this case, we only have 2. So if I say for I in calls print I, it's just going to print the first one and then the second one. Just like we want it to, right? So in this case, I might say Print I, and then the sum of that one. We even put like a fun.
What would the word unique mean again?
Unique means like, so if we look back at this data set, and we look at group, we see national estimate, and then by age, by age, by age, by age. So
Does it count?
it's going to count how many unique values are in group.
We want to define what those are. Like if you are trying to find like what is that is unique per.
That's kind of why I use count for that stuff.
Okay, that's what you would do.
Mm-hmm.
Okay.
So like here, I see that there are 4 unique indicators, and then within those there are 2,601 different observations or rows. Yeah.
And that's where you can add like inside the parentheses, like what do you want to look? That is like what column?
You want to do the square brackets first. So like what?
Oh, you don't want to do parentheses.
Just a second. Let me see here. So if I go df group count, it's going to count every observation. If I go,
I guess I was doing df dot count and then parentheses whatever the
Did
name of the column was.
did that work?
No.
Okay. Yeah. You have to reference the column first and then do it. You might have to group by it first. Let me find the name of that. There is it values count?
It didn't work, right?
It was like I said, no.
I tried.
So is that?
So I did count and it gave me
Just the big number.
all the big
Yep,
numbers.
yep.
So then, yeah, I was gonna try.
Try value counts. It's the one I've got up here.
Oh, okay. Okay, let me see what happens. Value. That's 2 words. Okay. Nope. Nothing.
What?
Ah, scare me.
Sorry.
I get scared either. He's gonna figure that out.
Oh yeah, you have to reference the one you want first, right? So
In
which
here?
column are you? No,
Inside.
with the square brackets before it.
So you're saying.
df.
Oh, okay.
df square brackets.
Okay, that's
Yeah,
what you
yeah.
meant. Do it like you. Okay.
Because now,
because like I'm just curious.
yeah, brand. This is exactly.
What?
Value counts, plural on the counts. I did the same. I did values count.
That doesn't tell me anything. You see, because I'm like, well, what's that?
Yeah.
I could do all
What
big
does your
and
data set look like? Does that
it's just Boolean. So will it?
Oh.
So if these are Booleans, well, that's what I was trying to figure out. Like, why is this just saying there's all true for this one, and so that's why there's only one count?
Yeah, I guess.
Oh, okay. That's what I was trying to figure out. Like, why is like I understood these. Like, okay, these have to have 2 different, but this one only has. Okay.
So if you summed that row or that column, you should just get back 922.
Right.
Yeah. And it even says frequency 922 versus false on this one, 555, meaning that there is.
I was just trying to double check because I'm like, well, all of these are two.
Yeah.
So this one. Yep.
Yep.
Okay.
Does that make sense?
Yeah, it does.
Yeah.
I just want to make sure what I was looking at.
I guess I'm more asking, does that make sense with your data set?
Yeah, it does.
Gotcha. Okay.
It does. It seems like a simple data set when I'm looking at this true false, but still.
James and Ted, I don't mean to leave you guys alone. Is there any data that I can walk through with you guys? Are you feeling okay about stuff?
No, I'm paying attention.
Okay. Gotcha.
I mean,
Sorry, go ahead.
No, I just think it's going to be one of those things where when I have my data set that it'll be something I can get through a little, put some insights together with, right?
Yeah, for sure. And hopefully these little functions like this are helpful in sort of like gleaning some of that information and being able to do like the EDA that we've talked about. And I'll make sure that I make this one available and make sure like this data is up and stuff. So if you want to try and recreate this so then you can use some of these functions on what you're doing, I want to make sure that that can happen.
Awesome.
Yeah, that's why I'm here.
Well, I can't promise that. I probably will. No. So I have my columns right here, and I put for I and columns. Then print. Some is no data frame.
This is
Right?
going to be dumb. You need a semicolon after your calls.
Oh.
Because it's like a phrase. You're like, Brian, call, do this. Yep. Oh, no, just a regular colon. I'm an idiot. Not a semicolon. I misspoke. Should work. Hooray!
Oh,
there are no nulls.
Oh, I have clean data.
Congratulations.
Thank you. I went through all of that for 0.
That's how it goes sometimes. All right. That's why with the Iris data set, when I wanted to like fill in stuff with nulls, that was a clean data set too. So I purposely put in like nulls. Yeah. Okay. I really want to find.
So then, am I going to get docked if I can't do like any cleansing technique? Okay.
Nope.
I think he just wants to see like what you mess around with and what
Yep.
you discover from it.
So I'm going on every bullet point.
Yeah, no, me too. I was doing the same thing. I'm like, because I did it, like, well, I just cleaned it. That's exactly what I did. That was the one my goal was.
Being black dots, but there's 2 of each one, so 10 technically. Oh, I need to save this. I'm at least so mad.
Yeah. Everybody make sure if you're doing work that you're into, that you're saving it. Yeah. Values count is the one that I forgot about values count will allow you to do stuff and not group it. And I totally forgot about that. So if we go, and I don't mean to stop anyone from doing anything, but if we go back to Charity's data set, like that's what we did here to get group. Like this is a lot cleaner. Now I don't have to index. Like I was using the reset index and grouping by and then counting that because that was easier. This value counts does all that for you. So we've looked by group. If we look by state, we should get, there we go. So United States, we have a lot because there was by age and then there was the national one. And then we got everybody else. And then here's one other thing, just if you want to make things pretty, after value counts, if you go to frame, then you get a pretty data frame like we were kind of used to, if you're into that. But you don't have to. And I wish I could remember.
Okay, trying to do a vector function again.
Yeah.
I want to say, basically, like I want to see all brands that are all vegan, like true. So it'd be equals true. So I'm like, okay, that's
You want to see all brands that are what again?
all vegan.
Oh, okay.
So it would be like for I.
So
No.
I would do this.
What do you say? Like all vegans equals true or something like.
So for this one, let me see. I don't know if this one only has NAs, or this one does not have NAs here. So quantile range in this data set is mostly NAs, but there are some of them
Right.
where it's not NA. So I might do something like, so DF, so new DF equals DF. Well, I might do something with this. Sorry.
Okay.
So I might make, we want to get true falses,
Right.
right?
Yeah.
So for yours, it's already true false.
Right.
So you
I
could
just
just,
wanted to display like how many, or I guess which. Oh yeah, I guess they think they show brands. So show me brands that are all vegan. I guess that was.
so I would do all vegan as its own thing equals DF and get that column, however that's spelled. And so this is going to pull that column of all those true or false. And you've got those in a list now. So then you could put them in your regular data frame and run that. I mean, this is going to error for me because it's not my data.
Of course.
Because it's already, I mean, the beauty of it is you already have it in Boolean. So you just need to call that column.
Right? Show me. Okay. So it just. Okay, no. Let me look at. Because the brands are there.
Did you, I think the brands got turned into Boolean.
Okay. Okay, let me see the beginning.
Keep going. Because now it says brands just true.
Okay. That's probably because we did this.
So where's your new calls? Go back up. Is brand in that?
And
It shouldn't be.
It shouldn't be, but sorry. Just trying to.
No, that's okay. I want to figure this out too. So go back up to when you converted everything to brand. So for in new calls.
But you just say everything in the data frame to Boolean. That's what we did.
Well, every column that's in there.
Which is the brand.
And brand is in new calls?
No.
Because you're only iterating through new calls.
Okay. Well, no. Then if not, then the new calls is this.
Right.
So no.
So it shouldn't be, but it is for some reason. Okay, humor me real quick and just run that chunk.
This?
Yeah, just run that chunk. Make sure we have that updated.
And then go back down here. Right?
And then go back down there and run, where you did the loop.
Oh, got it. So, and I'm keeping these because I want to show you.
Sure, yeah. So run this again.
For the loop. Okay, it's giving me an error.
Oh, because
Beauty Bay. It's not. Let me look here. I wish it was
so
easier.
in this case, I feel like your data, you've been referencing the same data frame a few times and looping over it a few times. So if they were already Boolean, they may. Anyways, what I'm trying to get at is it might be a good time to restart your kernel and run everything from scratch.
Okay.
And get like a fresh data set.
Okay.
So
just restart, right?
Yep. And again, your code is all there.
Right.
It's just everything that's in the environment. Okay, so let's go up and start running some chunks that you know work. Right, so this one works. Go ahead and just, start running this. That's good. Okay, run this guy. That's good. Well, yeah. So this stuff we know all this stuff is going to work. Let's get down to where we start doing.
This.
Yeah, run this. Okay, so we got the new calls.
Okay, and then go back down to the 4i
Yeah, let's go to that.
right here.
So df4i and new calls 4i. Yeah, go ahead and run this. And then.
Nope. What did it do?
That's okay. This is good. This is what I was wondering. Keep going down.
Beauty Bay.
Oh, you have a comma in it,
Oh,
right?
yeah. And it should have been outside of that. Well,
So run that. Let's try it again.
I'm mad about that.
I mean, just so you know, this happens to me. I've literally done this in front of you guys, and it's not worked. Okay, let's see what happened this time.
Colt Bay. Okay, let me look back then.
Yeah, double check to make sure everything's
I'm
named.
sorry. You said there's not a, no, there's not a. Remember, I was looking for that blue thing. But,
Yeah,
But not this one.
errors don't have it. Yeah.
Oh, really?
No, I don't think so. Only when you're like printing data.
And it was Colt Bay. No, but let me, just to make sure.
No, and so this is why sometimes like I will do when I'm making a list like that I'm going to iterate through, I might do df columns or whatever my data set is and then directly copy from that because
So do you want me to just copy?
well just make sure you're referencing the columns properly because
Because this is the,
because your data set is saying that there is no column named Colt Bay in there.
yeah.
So
And
what
Let me look. Oh,
Colt
Colts.
Beauty.
Is that what it is?
There's Beauty Bay and Colt. Yeah.
Colt. Yeah. Okay. Yeah. That, because I'm wrong.
No, that's again. This is 90% of data engineering analysis. Yeah. What? Yes. And then Charity, I'm going to come over to you because you haven't said anything.
This works for me just fine. This
Yep.
works for me just fine when I just said average viewers. So I'm trying to group and compare to look at like the average viewers and the watch time average
Yeah.
by the language.
Okay. You're not going to like what I have to say. So it's not running.
Yeah, because if I just do it like this and I just look at the average viewers,
Yep.
it works just fine.
Yep.
Now I'm like, okay, well, I want to compare the average viewers to the watch time because I'm just curious to see, like,
It's more-
I told you that, like, the language around the world, I want to see, like,
Yeah.
the watch time.
Yeah,
of the
this
viewers.
is great. Yeah, yeah. So it's because brackets.
Right.
Remember, we need to, if we're calling, I know. That's why, again, I like to make something, so I don't have to have brackets on brackets on brackets. I like to have something like I have here, where I have everything that I'm going to reference in there.
Also, I need to do, like, an index.
No,
I mean,
indicator, let's go, groups. So I have like two things here. Like if I wanted to, I could put these things in here. Or if I wanted to like call them within a data frame, I'd have to have it on here. See how I have two brackets? I have the brackets for the data frame itself, and then I have the list within it. And so I have double brackets because the inner brackets are a list object. Just like I have.
double bracketed it, it should work.
Yes. And it's the same as if we defined this list before we put it in as its own thing. That way we don't have massive amounts of brackets. Well, it might be because you might need to group by that thing again. You might need to group by multiple things. I mean,
Oh, I think there's M's. Okay.
all right. Well, it was also the double brackets, I
Brackets,
think,
okay.
too. But yes, you're dealing with the same thing that Brenda's dealing with.
And this will show the language and then the average viewers and how long they watch.
Cool.
Now, if I wanted to change this into a percentage, then I would have to do like an aggregate function on there.
So you want to like divide one by the other?
Like, well, I guess it's not even a percentage. You know how like you make the average viewers? Well, I'm probably going to do that. How would be like 5 point whatever K.
Yeah, so there's watch time and then there's average viewers. So if you divided watch time by average viewer, you would get the average watch time. Wait, average viewers and then watch time. So that gets a little tricky.
I won't worry myself about it. My brain gets to turn.
No, but I know what you're trying to do, and you're doing analytics. Like that is something that people would want to know. Yes.
I know you were going to go to charity, but so it did go true, false. How do I, to what can I write to change the brand to, what would it be into? It would be integer, I believe, is how they.
No, I don't think you want to do because it's a string.
No, a string.
Yeah.
Yeah, right. A string.
Did you send me this data set? I'm
Yeah.
gonna mess around with it real quick, and then Charity, I'm coming over.
But is it because we named it new calls? No, because it was.
I don't know. It's weirding me out. That's why I want to take a look at it to see what we're doing wrong here. All right, Slack. Can I download this, please? Yes, download. Okay, I want to download it in data. Download. Okay, it's downloaded. Data. Okay, so unnamed. That's stupid unnamed.
And what did we do?
I won't worry about that for now. Wait, can I do? No.
It was.
Yeah, I was trying to see if I remembered how to. Oh, no, that's the first row.
Practice. It was df dot drop parentheses df dot columns bracket 0 comma axis equals 1.
Okay, I'm not going to worry about it for
Okay,
now.
good.
So these are the ones.
That we change into.
Yeah. Okay, so calls equals. Ooh. Now I think Cult Bay is like a cool band name or something.
Right. See me rocking it on. You know what happened.
Cult Bay. Okay, so for I in calls, print. Let's go head. This is just me making sure this is working how I would want it to. Head is not defined. Oh, I'm an idiot. Wrong syntax. No, it's not. There we go. All zeros. That's what we expected. Let me do this real quick. Starting out all zeros. Okay. So let's go. I just want the sum of those ones. Okay, so those are all the falses. Okay, so far it's working how I want it to. So now let's go dfi equals dfi as type bool. Did I spell something wrong now?
No, it's capitalized. And that's capitalized.
Oh, dun, dun, that's not DF. Named it Brenda.
Special.
And then it didn't do it for me. So this is kind of why I mentioned earlier, like, move all your stuff over to like a clean notebook without all the other stuff, because that other stuff can like muddy up your
Okay.
environment.
I will.
I mean, does that make sense?
Yes.
Because you could end up,
And we even had trouble like
yeah,
when we were doing it.
and that's the story of notebooks. Is they're great for EDA, but after a while, there's so much stuff in your environment that you're just like, things are working and then they're not working, and you don't know why they're working, or you don't know why they're not working. Which if you have like a nice clean one that you can always just run all cells and everything runs perfectly, like that's what we want.
I'll do it again and then
How's it going? Do you have any questions on anything? Is there anything I can help with?
Not yet. I'm just watching the video.
Okay, cool. I just got my shoelace stuck in this wheel. That's fun. How did that happen? Okay, come on. Really? Okay. Anna, how are you doing?
Good. I just don't know what like questions to like ask with mine.
Cool. And we went through yours a little bit. I could kind of take a look at it again.
I think we found out yesterday like the same day. And I think I told you something. I have to go back and like what we're using.
Oh, you don't worry about that. It's your stuff. I'll run mine from yesterday.
I thought I was working on mine and I was on yours and I deleted whatever you gave me.
Oh, well, it's in the Slack. So if you need to
Yeah.
re-download it, yep, it's always there.
Yeah, so I'm just looking at what I haven't deleted.
Oh, and that's gotcha. Status. So one thing, Anna, that I just did that might be of interest. So I wanted to, again, with value counts, we can do group buys a little quicker. And I did one, and it's like length 100, but it barely gives me anything. It's like, how do I work with that? Remember, if we set our max rows display, I'll set it to like 200. Run that. And then if we run it again, there we start to get stuff. It's a little wacky. And then we can always do to frame to make it prettier. And so I don't know what the status is. But this starts to get interesting to me. Like,
I think it would be like the type of if it's open or closed.
yeah. AAOA, JAJO. Interesting. Can I do order by? Nope. Holy. Oh, it's info. That's what it is. Okay, so yeah, this is, I was trying to remember what function is super helpful that will do a lot of like the NA checks and stuff like that. And it's just info, which is stupid that I couldn't remember that. So if I go to like Brenda's original one and just do Brenda info. So I see that they're all non-null, and I see Boolean. Oh, I guess I changed some of them already, so that doesn't help too much. But I still have. So here's charities, and this is helpful that I can see these are strings, and then these read in as date times because I told them to. Float 64 objects. We see there's very few there. Can we do this two frame? I don't think we can, but I'm gonna try anyways. Nope. But this is sort of something that is, I guess it doesn't really give me the counts, but that's still pretty helpful. Maybe we want. Maybe I want something like this. Maybe if I want to get like the total groups. DF, D types. Can I do that? There we go. So df object, so equals that. And then I can say, no, that doesn't work, does it? I in okay. That's not right. Ah. Hmm. Okay. I'm an idiot. Let's try that one more time.
On Notable, when we upload like our notebook, you also want us to upload the data set in Notable too, or no?
If so, I had issues uploading the data set to Notable. Were you able to do it?
Well, I had uploaded the wrong one, but yeah, it let me upload one. Like this, and let me know if I need to do more. I just kind of,
And so this read your okay.
and then
So
my data.
So I don't think this will run though. Like I know it's right now it's just reading the output that you had in the Jupyter notebook. Cool.
Which kind of, how do I know if it'll run or not?
So try and so the first column you should be able to run. So hit the play button, and that should be good. Yep. Yep. So this should error because it doesn't have that. I think the kernel's still starting. Wait for those guys to. There we go. Yeah. So I was having trouble with this. I wasn't able to find like an easy way to upload data. You can try and go to like file,
Can I just do upload over here?
try and try and upload the data set. So your Twitch, yeah, try and upload that. Okay, now you should be good. So now if you run your final one, it should be able to run that. If that's how easy it was, I'm an idiot for not figuring it out. So run that, it should run quick. Yep, so it's good. Try and do this. That's it. Yeah. So your stuff is now running in Notable.
Okay.
So the cool thing that I would do here is let me pull somebody else's stuff into Notable real quick. Charity, I'll pull yours in.
Yeah, it's cool right here. Like it's showing me like my watch time and all this stuff, like almost like
So yeah, so it's basically like you're just running a Python notebook in a different. You're not running it in Jupyter Lab anymore. You're running it in Notable. So you did sort of like the brute work in Jupyter Lab. Now you're Notable. You can run that stuff. But again, the cool thing to me is the visualizations. So let's get started. This is still showing up, yeah. And this always happens to me. It never works. It worked. Okay. So my first project. So upload. That's how easy it was. God, I'm so stupid sometimes. Mental health. Upload. Now I would say, Anna, if you want to do this, yours might be you can up to 25 hours. File size of 100 megabytes. Yours was like 180, right? Yeah. If you want to use like a subset of that data, that's acceptable. Like if you want to use just all the, like I think it looked like Hollywood had like a bunch of observations. You could filter and say just Hollywood, and then you would use pd.write CSV, and it'll make a new CSV file for you. And then you could port that into Notable if you wanted to do visualizations there. So that worked. That's great. Let me copy that. NHL data, not really.
Could you define things that I try to define, trying to do an argument, trying to define false to like print out as something else just to like play with it.
Mhm.
But it wouldn't let me, like the word false, is that a word that's saved? So
Yeah.
I try to do like parentheses or quotes. Wait, no.
I think there's a command to do that.
Parentheses, yeah. No, quotes.
So did you already start doing it? Nice. Let me take a peek real quick. And then I'll take a look at it.
No worries.
like it's making graphs to me right here. Like,
Oh yeah, so it's
like,
already
right.
giving you like distribution and stuff, which is nice.
When my graph is coming up, I just have to.
Cool. Yeah. Okay, so you're doing.
I'm trying to do this. And I was like, oh, let me just play with that. So I did.
Oh, you're trying to make a function. Yeah. Okay.
What did I do with it?
Was it in a different
Maybe.
notebook?
Yeah, it was in this one. So
Oh yeah. So false is already a thing.
Right. Because it does the, when I took out the thing, I'm like, okay.
Yeah, it's probably, so when you run that, does it say no?
Yeah, it says invalid.
We'll run it real quick.
Invalid syntax.
Yeah. So false is like,
Oh, it's saved. Right.
Yeah.
It's like a.
so if you look at it, turned like bold green,
Yeah.
meaning it's its own function. You cannot
Yeah.
overwrite it.
And and I'm assuming that's the same for true.
Yep.
Okay. So I can't really.
What are you trying to do?
I'm saying like if if it has false, then like just tell me that it's, instead of saying it's false, just tell me it's no bueno.
Oh, okay. So you could do,
But yeah,
I was just saying, like, just make it
yeah, no,
print a different thing.
for sure. So define is this false? And you're going to have a value go into it.
Return, yeah.
And then you want to, if X is false, return no bueno. So that worked. So then if I go, is this false? With which ones did we have? Yeah, Sephora had some falses. Oh, no. Those were Boolean.
Yeah.
All vegan. Let's try that
all of
one.
them, yeah.
So
So you would have to do it inside. Why do you put X on the inside of the parentheses?
let's just see if it works. Nope. Why did you get mad? The truth value of a series is ambiguous. Use bool, item, or all. Maybe we need to do for I and X.
English is in British.
No, in Portuguese.
You said English and Portuguese.
Yeah.
So English as in UK, or are you talking about American?
Language.
Oh, and
It's a favorite language.
got it.
People who speak English and Portuguese
So
sit on Twitch longer.
I'm gonna have to think. Okay.
It's a little wacky.
I need to I need to think that one through
Yeah.
of how what I'm reading it.
So if we look at this, if we look at what we're inputting, putting in this.
Right.
And so this is X. So X is what we're feeding it. That's our argument. And so now I'm saying for everything that is in X, for I and X, if that X happens to be false, print no bueno.
So is it because you define is this false as X, you don't put is this false for the X, right?
Right, because we have to iterate through it.
Got it.
Yeah. And then we could do else print bueno.
So when does return become appropriate?
So yeah, that's a good question. So this, yeah, so then it's different. So if I do return wants to just give you one value back. So if I do this once, it's just going to give me no bueno because that's the last one that came through. And if we look, oh no, it's not. Was it the first one? It was the first one. So that one doesn't want to iterate through. Yeah, I'm trying to remember why it just does that. So print gives us text, like what we want to see, something that just tells us something.
Something came out.
Return is like prepping the output that you're getting can be like piped into something else then. And so I think, so if we did this, make sure my boss isn't making fun of me. So you'd almost want to iterate through it before it went in the function. So I would do something like this. Let me copy this. Bless you.
Thank you.
What have I done?
That's what I said to myself.
Yeah, it got mad at me.
See, mine didn't go through, but mine was the colons. And so like the colons were unexpected error. I'm like, no, that has to be there.
Oh, I'm an idiot. That should have worked. That's what I thought. So it's returning that, but it's not printing it. So maybe if I do print. There we go. So yeah, returning is not going to,
Do the same thing as the print.
yeah, like what we want and like
Show
what
me.
you're accustomed to is like show me the money, right? Print will give you, a return will give you something, but maybe not in the sense that you're used to, because again, it's getting ready to, it's prepped to go into another function or pipeline or something like that.
So when I did mine, I did it different from yours. I didn't do it as it's supposed to.
Mm-hmm.
Mine was just def is underscore false x colon for I and x equals false. Right? Bueno. But this is the problem.
Yes. So we need a
What am I missing?
we need a semicolon after anytime you do if
Oh,
or define or for anything like that. Yeah, no, Rochelle and I were just dealing with the same thing, so that's legit.
What happens if I want to add?
What's up?
to my notes?
Yeah. What's it?
So, I'm trying to figure out how you did this. I
Uh-huh.
have it right, but it's not getting there.
Doesn't look like you've imported Seaborn.
Oh, so I gotta import something.
Yeah. And so that's just import Seaborn as SNS. Here, I'll show you on the screen too.
I think you did it too fast. That's what's watching.
Yeah, sorry. Just tell me to slow down. So yeah, and I can put this, I'll make sure to put this in the chat too. Let's see how I got the import up there.
Oh,
And so now the import that Seaborn is imported and aliased as that, then you can call SNS dot line plot or bar plot or anything like that.
So I would go to Seaborn .pydata.org frame. Or can you show me how to? import?
Yeah, you just write import at the top.
Oh, that's all.
Yep. It should already be, Seaborn is pretty standard. It should be on there.
You go back to the top and tell me
Yep.
kind of what you and what else I need to do before next week. Which one do you want to look at? This one or just this one? Doesn't matter.
Well, they're pretty much the same, right?
Yeah.
Yeah. So I mean, everything in this is great. I would say if you're doing stuff in Notable, like, were you able to get any cool visualizations from that?
The only one I got was this.
And that's
I did that.
that's Seaborn, right?
Yeah.
Yeah. So let me open up.
And then I did you confuse one or two because I said
Oh.
you said I had to make like an analysis.
Yeah, that's great. Perfect.
That's cool.
Yeah, yeah, absolutely.
Okay. And then you said to do something. You want me to add, like putting a graph or something in here to Notable?
Yeah, that's if you're going to use Notable, that's I would definitely use something there. Let me run to that real quick. Okay, so I think I have. Don't have K-pop. There we go. Copy path. There it is. Oh, I didn't run pandas, did I? Nope. There we go.
So I just give me the other thing. How do I get it back?
Try undo. Edit, undo, maybe. Where did you delete? Like,
It's no longer here anymore.
so go to edit at the top. Let's see if you can. Yeah, undo. Oh no, now it's. So it's putting in that stuff now. Did you just edit? Here, if you just do Control Z, you can do it like a bunch of times here. So, is it this stuff? Is that too much? It may have gone back too far. So you might want to redo. What's the go to edit real quick. Redo is, oh yeah, Shift Control Z. Let me put it back. Oh wait, there it is, right? SNS.
Yep.
There. Is that it?
Yeah.
Okay. So you still need to import that other stuff. I'll send you a Slack message with that code, since I just undid all of it.
Oh, well, do I import it before or after?
Yeah, you need to import everything at the top.
Before I do all this?
Yep.
So would it delete this then?
It should not delete that. No, I don't know why that got deleted. That's very strange to me.
Let me save it first.
Yeah, definitely do that.
I think I remember
Okay.
import as-
And I'll pull it up here so you can take a look.
It still has it still says it's still the colon, even though.
Yeah, you need one after false. Do you have
You mean this one?
after that one? You need a colon there, and then
So you're saying this?
yep, and then you want to tab print over one more time too.
Like that?
Yep.
Is that needed? Like,
Yep,
will it know?
The tab, yeah, it needs that.
It's sensitive that way?
Yes. So now there you go.
No, but I wanted.
So you just defined the function. You haven't run it yet.
Oh,
So now you're saying there. So if you put in the data in there now.
okay.
So
So if I did-
parentheses.
Right? It's whatever.
Well, you want to put whatever your data frame
Right.
is, square brackets,
Oh,
the name of it.
So I click on add project.
So parentheses first because it's a function. And then within the parentheses, what's the name of your data frame?
okay, I'm a little, okay.
That's okay. I know
It's just DF, okay.
DF, and
And
then,
then it's the,
square brackets.
yeah, of whatever you're trying to
Yep.
call it, right?
Yep.
Okay.
I don't think you need the period.
You know,
I don't think so.
okay, maybe you're right. I don't know why.
That's all right. It's like you're learning another language,
Yeah,
quite literally.
no, not brand, because that's not,
Is it Alto one? Yeah, there you go. All beauty,
all vegan.
all vegan. Are there any? Is that one completely false?
Yeah.
Oh.
So that means there's no all vegan.
I didn't think
Products.
that one was all false.
Me either. Because, you see?
All vegan.
Oh, I put black owned.
No, but that's after.
Lines is this, and then
Let me try that in mine.
the one that you did was all vegan, or
Yeah.
yeah.
Oh, that's it. It's only returning false because it's only returning the false values.
Oh,
You didn't do
that's
so. In
else then.
I did an else
Okay.
semicolon and then yeah.
Um,
So it was working as expected. Like if we would have counted those falses, it would have been the total amount.
you put return, but I want to do prints.
Yeah, do prints.
All right.
Because yours is iterating through. Mine is set up to be a function. So run. Did you run that?
Yeah, but I still did it.
No, try it again. That should be right. Run that, and then this didn't work. It didn't work.
And this is this is right.
Did your day? What's?
We can look back at the.
Oh no, there's a false and a true right there. And that's just D, and that's what you called, right? DF?
Yeah, it's just DF.
Okay, go back down. Let me take it. I. Oh. So you did for I in X equals false. So you're already saying that X is false. So take a look at mine. So I did, initially I did.
Right. You went
For
through a lot
I-
of- that's why I'm like,
Yeah, sorry. So for I and X, and then colon, enter. So do a colon after the X. Enter. If.
Oh.
No, sorry, yeah. So if I. And so see how your if just turned red?
yeah.
It's because you didn't tab. This is exactly what we were talking about. So if you do one more space. Oh,
I thought it was like,
There we-
okay.
tab,
Okay.
one more tab. There you go. If I equals false, and then print that. So you want to tab the print over one more time. Every time you do a colon, you want to tab underneath of it.
Like that? No.
The one above it, sorry.
Oh, okay.
And then print. Both of the prints need to be tabbed over once.
Okay. Because it's
Because you did a colon. Yep. Okay, let's try it now. Come on. Yeah. All right, yeah.
this is something okay.
I mean, I'm very proud of you for trying to do this,
Yeah.
because this is not easy. So you're going above and beyond a bit. So that's great.
Yeah, I get it.
I don't
Keep
have
working
the DEX bar where I can make the,
Yeah, did you get it working?
no, this, it just shows locked right here, and I don't have the DEX demo that'll let me.
Oh, did they take it off?
All this there is just here. There's-
What? No way. Okay. So when I did mine, I did data equals read it in, and then I just put the data like you would, like right here. Here, I'll zoom in a little bit. And let me get rid of this thing. And so when I print that, resize, export, configure, yeah, and then I'm in.
Okay, hold on one second. Let me, so I need to add still below. And then, I'm in the whole to read.
Did it work?
I'm typing it.
I'm too zoomed in. There we go. Oh, mine still hasn't even run yet. Let me do a big hard refresh here.
And you just put data below it.
Yeah, but mine claims that it still hasn't even run. Starting kernel, okay. Says it can't find K-pop. That's okay. We don't need that. I'll just delete it. Okay. Okay. Well, at least yours is running because mine is not.
Oh.
Did it work?
I know, just, make simple things hard.
You and me both. It's all right.
Well, the whole configure is what you're saying, the press, right?
Yeah. So if you hit configure and it should say like prism.
So I can do configure for a couple of things. I can do it
Yeah,
for the
yeah.
head or the tail. So if I wanted to do it for like the head,
You could, yeah. This is a small sample set.
and then it's here, right?
Yep. So that'll give you the suggestions. Yeah, there you go. There's already stuff. Some of this stuff might not make sense, but it'll give you a
It
starting
still looks
point.
cool.
Yeah, and if there's one in there that you're like, oh, that's cool. So again, if you're using head and tail, you're only getting a very small amount of data, right?
Mhm.
So just like don't put anything, just write out df. Just execute df as a command without head. And then you'll get the whole data set, and then you can do stuff. What's up? I'm sorry.
Everything's becoming red.
Okay, scroll. Let's see what the bottom. Cannot insert level out. No, he does. Yeah, I just want to read that. The bottom. Cannot insert level 0 already exists. Okay, scroll back up. What did you try to do? Keep going to the code chunk. That looks right. Can I see some real quick?
Mhm.
Okay, let me go.
I don't like this one with the followers mature and not mature.
I was wondering about that too. Yeah.
Mhm.
Okay, so that's good. That's good. Okay, here's one thing. There's a comma right there. It needs to go there. And then shift enter. There we go. Shift enter. There we go. Okay. It's the little
I don't know why I
things.
didn't realize it the first time it worked.
Yeah.
Can this command be in quotes if I try? Oh, sorry.
Sorry.
I'm trying to just show like the brand and this so I can see that, because like it tells me this, but I want to know like which ones. So
I know what you're trying to say. Yeah.
can I do is false as the, or it has to be all the, like I wanted this, apply this to be here, and I want the brands. So I want to, oh shoot, How did I undo this? I don't know how I made it.
Oh, just click off the. Oh, wait. So you went to Markdown for some reason. So go to code, and then you can
Is that the same thing if this were to happen? If I did it, I did it a while back. You had
Yeah.
Okay.
So I think you can do. Did mine run? Mine still didn't run. Okay, let me go this. That's going. Let me go back to this. Hey, it's going. That's great. So I'm gonna say
if I just want to add the brand.
right.
And when I do
So
PDF,
for me, I would do, and this might work for yours. I know ours are set up a little bit differently, but I would do. What have I done? False. Oh, you want the brand? That's right. Mm-hmm.
I just want to add another column so I know.
Right.
No,
Since you're iterating through one,
Right.
it's tough to do it with the other one.
Yeah, I knew. I was like, I know there's a.
So you're starting to go down the path of wanting to iterate through two different things at the same time, which if you think it's messy now, wait till you do that.
What would be like on the one, one of those guides? I was looking to see. I mean, I looked at functions. To see like
Jay and Brenda. Community to unpack. Let's see if I can do. Can I?
Can I do a lambda function?
Trying to remember. I haven't had to do.
Sorry.
No, that's okay. I really wish. Valid syntax. Too many values to unpack. Expected to.
No big deal. I was just wondering.
Hold on. There's one. Let me see there. And then. Okay. So we are going to reference the index to hit both of them. So if I say for I in range 0 to length valid syntax. Are you serious? Oh. Okay. So when I do length of this one, I'm getting the number. What is it, like 722 or something like that?
9.
Or 9 something. Yeah. Oh yeah, actually I could probably scroll all the way down and see it. Yeah.
922.
Yeah. So when I do range, it says start at this first number and then iterate all the way through
Right.
till the end. So
And that's where the length comes in. All the way to the end, or what is the length?
that's where the length is. Yeah. So then I could say print Brenda, and we want brand.
Brand.
And then, so you're going to hate this a lot. If we want to reference it by the index, we need another square bracket. That's where we're going to put our I. Similarly, we are going to put, I said you wouldn't like it.
Yeah.
Brenda, also I, and then this is all vegan, right?
Oh, yeah, all vegan, yeah. And then, yep.
Now mine is different, so it might not work. It did work. And then I might even put like something to distinguish. So I might put like a dash and then something like that.
Yeah, okay. Leave it like that, and then I'm gonna see if Wayne does.
Yeah.
Oh, God. You forewarn me.
But I mean, I like that you want to try to do this. So like, it's not all bad.
Yeah.
Okay. We are at time. Obviously, yep. The guys already left. Private chat. They're probably saying, we're out of here. Yeah. Sorry, guys. I meant to let them go. They're good.
Oh, I just made a really cool pie chart.
Do you want to go back?
Yeah, yeah.
My thing, you can come paste in there.
How about
Not
save
worry about it
this?
on the slide.
Oh, that's fine. I'll leave it here. Actually, yeah. This is what I want to know because I haven't done this yet. See if so. What did you make?
So
Oh, nice.
this is the rounded watch time by
Yep.
the rounded average viewers. But this is where like
Oh,
I was just reading the data,
yeah.
but like in my analysis, I noticed that the English and Portuguese have longer time that they're actually on it, but less watch time than the Spanish and the less average viewers in the Spanish and the Russian. So like we're spending all this time scrolling, not even making a selection. They're spending more time actually viewing and then getting off.
Yeah, that's crazy.
Point.
Cool. Yeah. So let's try and export this. So go to File, Export Notebook. See if there's like, nice. So do PDF, and let's see what that looks like. It might look gross. If that doesn't, try it again. Oh boy. Oh, okay, it's going. We just got to be patient. Charity, I've seen red on your screen.
Yes.
I'm coming.
It's still the last part.
What should it say? No.
Once open that up, see what it looks like. Whoa. Is that what it looks like? Oh, those are the print
Configured
things.
ones,
Yeah.
yeah.
Okay,
So I did
that looks
that.
good. Oh, that came off. Try and export it again as HTML. I think HTML is what we want. Okay.
Can I also download it on here?
So
I
it
don't
can't
lose
just true when it's still doing the same thing when it falls.
Okay, let me, scroll to the bottom of the red, and I just want to see what the error says. Keep going all the way to the bottom of it. It's always where the good, okay. Got unexpected keyword. Oh, you spelled legend wrong.
Oh.
That's, welcome.
And see, I was looking at it, I was like, did I spell it wrong?
I mean, again, you've seen me spell everything wrong, so.
I think HTML
No.
is where it's at.
You
No,
do?
we
Or,
still cut it off.
really?
Oh, sorry.
That's what I was my pie chart.
Dang it.
And it didn't even load this one.
It just looks this. Yeah, it didn't.
It didn't even show the round two.
Okay, see if you can share this note. So go back to it. Go to share. The big, yeah. Type in THOM and just see who pops up. Okay, try. Let me see what my, I don't know if I'm Thomas or Tom on this. I'm Thomas. So type Thomas and then FL and it should see me. Yep. So go add as and whatever you want. Viewer is fine. And then done. Oh, yep, it should be good. Now I'll see if I can see it.
And then all the changes I made here, is it going to save it automatically?
Yep.
Okay.
So if you continue to work on this before Wednesday next week, I should see it.
Is there anything else you could suggest that you would like want to see?
Anything that I would want to see?
Yeah.
Um,
So I kind of showed you what I
for sure. You've done quite a bit.
I want all my points.
Yeah. I don't know. Maybe just play around with like one more visual.
Okay.
And then I'm trying to see if I can see your stuff yet. Thomas Flaherty. MySpace, you shared it. Did I get an email maybe? This is my Gmail.
Yeah, because it's all in my chair.
When you wanted to like give you like insights or like identify trends and stuff, do you just want it to be like documented or like just comments?
Yeah, and I went through all that stuff because when I wrote it, I was like, they could do all this stuff. As long as you're hitting like 3 to 4 of everything that's in there, especially the optional ones are very optional. The main things, and I'll update this actually, maybe just as we're in here.
Just kind of want to know that we can like look at the data and like.
Yeah, and I mean,
That's part of the beginner.
pretty much everyone has demonstrated that to some point. So I'm not terribly worried about anyone. Yeah. So was that 5 where I introduced that final project? So you guys selected a data set, you loaded the data set, you did cleaning and validation. Maybe you didn't have any, that's totally acceptable. Transforming feature engineering, that's any aggregation and any simple analysis. This is optional. Because your data set might not have it. Yeah, I mean, EDA is just like any type of aggregation that you did, like value counts on things and like maybe understanding why certain ones are high. Like for yours, why is United States so high when you group by state? And so maybe take that and look at the subgroups and be like, well, this one is big because of XYZ, like that type of stuff. Like just understanding like things that might initially look like anomalies in the data. You're like, oh, this is a big number because like these reasons. That's what I'm looking for there.